Okay, boys and girls, today we're going to be talking about division equations, okay? But before we can talk about division equations, we have to talk about the rule of multiplication. The rule of multiplication says that if I multiply both sides of an equation by the same number, the equation will remain balanced. Both sides will remain equal to each other, okay? Let me show you an example. If I say 6 equals 6, all right? We get this, that does, all right? But if I multiply 6 times 2, will it still equal 6? 6 times 2 is 12. Does 12 equal 6? No, it does not. So that's why we have to multiply both sides of the equation by the same number. 6 equals 6. If I multiply both sides by 2, I get 12 equals 12. That is a true statement, okay? I multiply both sides. I keep it balanced at the balance point, which is the equal sign. It stays balanced, okay? So let me show you two examples of how this works. And this is probably going to be a little bit longer video because there's some more stuff involved. All right, the first example, I have x divided by 5 equals 10. Now I know it's super easy just to say, oh, that's 2, Mr. Bell. I know that. Don't do that, okay? I promise you that will not work. All right? So, as with the other ones we had talked about, we have to perform the same operation on both sides of the equation, both sides of the equal sign. All right? So, x over 5 means x divided by 5. The opposite operation of division is multiplication. So if I multiply both sides by 5, that will give me the answer I'm looking for. Now this is why it happens, okay? Let me show you. Let's just say I have, how do I want to do this? 5 over 1, and I'm multiplying it times x over 5, okay? If I multiply, well, I can cancel these out. I can simplify, okay? Because on a multiplication problem, you can simplify the numerator out of one fraction with the denominator out of another. This now becomes 1. Then I have 1 times x, and I have 1 times 1. X over 1 equals x. Okay, so what that leaves me with is just x. 10 times 5 is 50. All right, so trust me on this. X equals 50. So that means this x equals 50. If we plug it back in, we can figure it out. Okay, so if I have 50 divided by 5, does that equal 10? Well, 50 divided by 5, if you can't figure it out like this, 5 will go into 5 one time. 1 times 5 is 5. I subtract, I get 0. 5 will go into 0, 0 times. 50 divided by 5 does in fact equal 10. That's a true statement. Let's look at one example, because I know your heads are probably spinning right now. All right, so now I have, let's start kind of high. 15 equals, let's say, n over 2. All right, you might be thinking to yourself, Mr. Bell, I can't divide 15 by 2. It doesn't work. It's not even. We're not dividing 15 by 2, okay? It's not working that way. What I have to do is consider this a division problem, which is what it is. I have to multiply to get the n by itself, because I want to isolate that n. All right, so I multiply by 2. That means I multiply this side by 2. 15 times 2 is 30. These two cancel out because this is essentially 2 over 1. All right, that leaves me n over 1, which is just n. So 30 equals n. You're not even going to the fact that the 15 was on this side and the variable was on this side. It could happen that way, okay? Don't let that confuse you. But if we plug in 30 back at the beginning, say 15 equals 30 divided by 2, okay, that leaves me with 15 equals 30 divided by 2 is 15. This is a true statement, okay? Don't automatically assume you know the answer, okay? Go through the steps, figure it out, go back and check. Make sure if you plug it in, you get the right answer.